So I want to talk a little bit about an introduction to kind of the math that you need for IB physics class and what their expectations are in terms of magnitudes of things, uncertainty, and significant digits and how that works. First thing, there's also okay, so one of the things on the IB syllabus that they expect you to know is kind of the order of magnitudes of things. When we talk about order of magnitude, we're really kind of just talking about powers of 10. And there's always a question on the IB exam that asks you approximately what's the size of something or what's the time period of something. I don't expect you to go out and try to memorize all these things, but you should in your mind have somewhat of an understanding of the relative sizes of things, okay? The order of magnitude, when we say, oh, that's 5 orders of magnitude away, what we're talking about is 10 to the 5th times away from one thing to another. So that's what it just means when we say order of magnitude. In physics, there are a large range of magnitudes of things. For example, the size of things in the realm of physics that we study go from anywhere from 10 to the negative 15th meters, which would be one of the smallest subatomic particles that we now understand, all the way up to 10 to the 25th meters, which would be the size of the entire universe as we know it. If you're doing some calculations and you come up with an answer that says 10 to the 45th meters is the size of that car out there, you should recognize that you've just said that that car is bigger than the entire universe. Okay, that's what I want you to know. So don't try to memorize the size of things, but just be thinking about the answers you get. There's an order of magnitude of mass as well. 10 to the negative 13th kilogram is about the mass of an electron, one of the smallest objects that we know about. 10 to the 50th kilograms is the size of the mass of the entire universe. So again, I don't want you to memorize these things, but I do want you to be thinking about kind of the relative scales of things. There's a little graph here, table that kind of shows you this. Again, just things to be thinking about. Here, in terms of time, for example, you know, a day is about 10 to the 5th seconds. That's 100,000 seconds, more or less. It's on the order, it's like a 5th magnitude thing. Your life, you know, your life will last a couple of billion seconds, you know, if you live to be an average age. So, but recognize, you know, again, over 10 to the 18th seconds, you're getting older than the age of the universe. That's more time than has actually passed since the Big Bang. So hopefully we won't be dealing with time scales greater than that. Uncertainty is huge, you guys, and uncertainty is something that we will deal with a lot in this class. Physicists, we talked about last time, physicists try to understand the universe, and in order to do that, they try to take measurements of things and do calculations. Every time you take a measurement, there is uncertainty, okay? Every time you take a measurement, there is uncertainty. And I'll explain that more in just a little bit, but one of the things that you need to differentiate between is what's known as random uncertainty and systematic uncertainty, or systematic error. Random uncertainty is the uncertainty that occurs because of the person making the measurement. Either the limits that the tool that they're using to make the measurement, or just the way that they take the measurement. Those things will create a certain level of uncertainty in every single measurement. That's random error. Yes, random error or random uncertainty. Systematic error is error, bless you again. Systematic error is error that occurs because the device has something wrong with it. For example, if I asked you to measure the length of something and I gave you a meter stick with the first 3 centimeters chopped off of it, and you didn't notice that the first 3 centimeters were chopped off of it, and you measured everything from that edge, all of your measurements would be off by 3 centimeters. That's systematic error. The tool that you used was not correct. If I gave you a scale to measure the mass of something, and when nothing was on it, it told you that it had a mass of 5 grams, everything that you weighed on that scale would be off by 5 grams. So that's systematic error. That's error that's inherent within the tool itself that you need to consider before you start taking measurements. Okay, so with the uncertainty, that's one way of looking at it. Have you guys heard the words and the terms accuracy and precision before? You dealt with that before? Does anybody have an idea of how to explain that? What's the difference between accuracy and precision? You were first, I think. No? Change your mind? Okay.
Accuracy is like you have like good dart.
Let's use the dartboard. And I like the dartboard analogy. I think that's a technology is great. Okay, I like the dartboard analogy. And this is going to do it again. Watch this. Okay, so we're going to. If you're at home listening to this, sorry. Okay. Yeah, come on. There we go. We can do that. So uncertainty. In physics, you will need to be recognizing when uncertainty is occurring. You will need to be able to state and also calculate and graph values of uncertainty. Okay? Generally speaking, in a very general sense, the smallest amount of uncertainty you can have, or the most precise you can be, using a certain measuring tool is equal to half of its limit of reading. Okay? The limit of reading is the smallest scale on that particular tool. You should be able to estimate to within half of that smallest scale, and that uncertainty is what's called absolute uncertainty. There's another kind of uncertainty, which is called relative uncertainty or percentage uncertainty, and it is probably a more useful piece of information. This tells you how big your uncertainty is relative to the thing that you measured, and that's important to know, because if you have an uncertainty that's 100%, that's a huge amount of uncertainty. 3% is a very small uncertainty. Okay, so this is often a more useful thing, and I know a lot of you are writing this down. I'm going to show you the next slide, which kind of summarizes it all for you nicely. All right, so there's three kinds of uncertainty we deal with. Absolute uncertainty, that's the uncertainty that's determined by the measuring device. It's half of the limit of reading of the tool. Relative uncertainty is taking that absolute uncertainty and dividing it by the thing you measured, and it gives you a relative value for how big that uncertainty is. If I take that one and multiply it by 100, I get what's called a percentage uncertainty. Let's see. Let's just take a look at this real quick. We take a measurement of 26.5 centimeters with a meter stick. What's the absolute uncertainty of that measurement if we use a regular normal meter stick? 0.5 what? But what's the limit of reading on this meter stick? Millimeters. So 0.5 millimeters, which is 0.05 centimeters. That's our uncertainty using this tool, assuming that we used it really well. Okay? What would be the relative uncertainty then? Because it's half of the limit of reading of the tool. And if I'm assuming we're using a tool like this, these are marked off in millimeters, so my absolute uncertainty will be half of that size if I did a good job. So, there's the answers. All right, moving on. So how about this one? Here are two measurements. 5 times 10 to the 6 plus or minus 1,000 meters. 2.4 plus or minus 1/10 of a meter. Which is a better measurement? Which do you feel more confident about? Which do you think is more precise? Top one. Oh. Okay, so some are saying the top, some are saying the bottom. Because?
The plus or minus is a smaller range.
Okay, because the absolute uncertainty is smaller. So which one is better? How can we tell? What would be a way of actually figuring out which one's a better measurement? Let's find the percent uncertainty. See what we get. Okay? Okay? This is why absolute uncertainty is not always the best thing. I mean, yes, you need to know it. You need to be thinking about it. But a lot of times it doesn't tell us much unless you stop and think this relative to the thing I measured. In reality, this was a much better measurement. It's very precise. Okay? This one had a greater amount of uncertainty relative to the thing being measured. Okay? The last thing that we need to talk about with uncertainties is how to deal with them mathematically. Whenever you add or subtract two numbers that have uncertainty, you add their absolute uncertainty. When add or subtract, you add their absolute uncertainty. Multiply or divide, you add the relative uncertainties. Okay?